I've introduced Pythagorean theorem, which is c squared equals a squared plus b squared. But if you have a right angled triangle, and again, it's only a right angled triangle that this works for, that the two shorter sides, so the ones that touch the right angle, the square of both of those lengths will equal the square of your hypotenuse length. So I suggested that if you find it hard to remember what to do, that you remember h squared equals a squared plus b squared. So I thought we could do some examples, and then I will show you how to manipulate it. So let's just make up some numbers. Imagine if you had 11 metres here, 15 metres here, and they wanted to find out the length of your hypotenuse. First, you would square 15, because that would create an area here. So 15 squared is 225. 11 squared is 121. So my h squared is going to equal, and make sure you do label for the examiner that you understand that it's h squared, not h, that 121 plus 225 will equal that. So that means in total I have 346 metres squared. But I need to know h. So I'm going to use my trusty calculator, and I'm going to press my square root button and then type in 346. Now it will come up with what's called a surd, which means it's the perfect answer. It's an answer that's not rounded, it's just using the symbol and whole values. You need to get the actual decimal answer, so you need to change it from a surd to a decimal. That's why it says S to D. Press that and it will give you your decimal, which is 18.60107524. Now, I'm going to use my disco calculator because my scientific calculator, some of the pixels have stopped working today. So let's type in 346 square root, and it comes up, can you see that better? 18.601075, so it gives me 2 less digits than my scientific calculator. Now obviously, that is a long number and we need to show the examiner that we can round. If you were using this calculation again, if you were using this number again for another calculation, you would use the whole answer. But whenever you get to a final answer, it's best to round it. So I'm going to round it to 1 decimal place, because I think that's fairly sensible. So I'm going to do 18.6 and then write down my units. I'm just going to underline it so the examiner can see it straight away. So we've been used to working with the Pythagorean equation when we know the 2 shortest sides, so the 2 that touch the right angle. What we need to be able to do is work the equation backwards if we don't know one of the shorter sides, but we do know the hypotenuse. Okay, I'm just going to label this so you get used to seeing it. So we have c squared and we know a squared, but we don't know b squared. So we need to isolate b squared by itself because we need our equation to end up equaling b squared. What we're going to do is look at what's on the wrong side of our b squared. So basically we're trying to isolate it, we're trying to make him stand alone without having any friends near him. So we're going to look at this. Now this is a positive value. So to get this to 0, so we can get rid of it, we're going to, at the moment it's really plus a squared. We're going to take a squared away from this side and we're going to take a squared away from this side, because you always have to treat it the same on both sides to keep them equal, to keep them balanced, because if you take something away from one side and that side is meant to be identical to the other side, you must take it away from the other side to keep them balanced. So positive a squared minus a squared will cancel, they cancel each other out, but now we're left with c squared minus a squared on the other side. So this would be the equation for finding another side. Now the easiest way to look at it is, if you know both the short sides, you use the equation normally. If you only know one side of the short sides, you need to take that away from your hypotenuse squared. Okay, so let's have a look at this. So we've got 64 squared, which I don't know the answer to in my head, and then minus a squared. So I'm going to just label these. A squared is 19 squared, and that should give me b squared. So I'm going to use my trusty calculator again. 64 squared equals 4096, and 19 squared is 361, and that's going to equal b squared. So 4096 minus 361, that's going to give me 37 equals b squared. So now I know what the area of the square that b would have given us. Now I need to know what b is. So b will be the square root of 3735. So I'm going to square root my answer, and that's going to give me 61.146432. Okay, and I just need to round it to a sensible length. So I'm going to round it to 61.1. I'm going to put my units in, which were centimetres, and just state to the examiner how I've rounded it, which is to 1 decimal place. And just put b beside it. And that's it. So just to recap, if you know this side and this side, just add them. If you only know one of the shorter sides, you need to take it away from your c squared. So you'd square your a squared and remove it from your c squared, and that would tell you what b squared was. So here is that equation. Job done.